Welcome to my video on Introduction to Probability. What is probability? Probability measures how likely an event is to occur. So probability is the number of favorable outcomes by the total number of outcomes. Say you take the simple example of flipping a coin. If you want to get heads, that'd be your favorable outcome. But if you flip it a dozen times, you're going to get heads and tails. So that'd be the total number of outcomes. So the probability is the ratio of favorable outcomes divided by total outcomes. And the value of probability ranges from 0 to 1. Let's just take the case of a magician's coin that's got two heads, for instance. If you want a tail, that's going to be 0 because there are no tails. If you want the probability of everything's a head, then it all come up heads because that's the only thing on the coin. But that's the unusual case, 0, 1. Most of the time it's somewhere in between. So theoretical probability is one form of probability, and that's calculating by reason. So in the coin flip example, we have heads or tails. We know of a standard coin that's not been doctored in some way. You're going to half the time heads and half the time tails. We know that. So that's the theoretical probability. Now, if we don't really understand that and we just picked up a random coin and we just don't know about heads or tails, start doing this experiment, then we're going to have experimental probability. We're trying to figure out the formula for probability for each event or outcome. We take the total number of times the event occurs, say whether it be heads in this case, divided by the total number of trials, and over time, so we keep doing this experiment over and over again. To coin flip 100 times, you might get 54 heads and 46 tails. So that would tell us the probability of a head is 54 over 100. Now, if we did it 1,000 times, it would converge more to 0.5. And so that's the difference between theoretical and experimental. There's also another type of probability called subjective probability. And this is based on personal judgment or expert opinion. For instance, somebody who's an expert in the field has done it many, many times. They kind of know what's going to happen. And so they'd be like a weather forecaster, but they use models and data. So they give us a 70% chance of rain. Now, everybody knows that's just a good estimated or educated guess. Subjective, based on limited knowledge or uncertainty. So in summary, we have really four types of probability. I didn't talk about the last one. Theoretical is based on logic and models or understanding of the physical world. Experimental, we're trying to understand what's going on. So we're taking data and trying to determine the probability of certain events occurring. Subjective probability has to do with expert judgment. And then the last one, which we're not going to talk about in this video, is axiomatic probability. And this involves set theory, and this will be subject to another video. This is for purely the mathematical definition of probability. We're dealing with it in more strict mathematics probability class. So let's go back and look at our examples again. So the theoretical probability of getting a head from flipping a coin is 1/2. Rolling a die, six-sided die, the probability of getting a 3 is going to be one of the 6 possibilities. So the 3 is your favorable outcome, 6 is your total number of outcomes. So that's 0.167. Now, if we pick a deck of cards and we draw a red card, we know half the cards are red in the 52 card deck and half of them are black. So that's going to be 1/2. So that's just some basic examples. Now we visualize probability, we can do these types of graphs. So let's take the example, we've got 2 dice now, and we roll them a bunch of times, and then we record the number. So it's going to be anywhere from 2 to 12, because it could either be 1 plus 1 would be the smallest, 6 plus 6 would be the largest. But you can see these have smaller probabilities because they're just one way of really getting that. But now, if you want to get like a 7, you could get a 3 and a 4, 2 and a 5, 1 and a 6. So there's more ways of getting a 7. It has a higher probability of occurring. So this graph kind of shows us over time, if we do this experiment many, many times, it's going to come out a nice looking graph like that. So let's look at another example. We've got a bag of marbles. There contains 5 red, 3 blue, and 2 green marbles. So the total number of marbles in the bag is 5 plus 3 plus 2 is equal to 10. Now the probability if we draw a red marble out, just pick it at random. You just stick your hand in the bag and pull one out. 5 of them are going to be red out of 10, so your probability is a half. Now the probability you're going to get a green is 2 out of 10, which is 0.2. And then the blue, of course, would be 3 out of 10. So each of those have a different probability. So this shows how to calculate the probability when outcomes are not equally balanced, like in the case of a heads or tail on a die. We've got different probabilities for different events. Now, one thing also feeds into probability. It's called this law of large numbers. As the number of trials increases, experimental probability approaches theoretical probability. So example is if you roll a 6-sided die and calculate the average. Now we know that if we get a die, we get either 1 through 6, so 1, 2, 3, 4, 5, 6. We add that up to calculate the average, divide by 6, and that's 3.5. So if we do this many, many times, we know that in theory, the average of all those rolls is going to be 3.5. Now at the beginning though, we got 1 or 2, 3, 4, 5. As we just get smaller numbers, see, first two dies are 1 plus 2. Well, that's going to be 3, so the average is 1.5, so it's way down here. Now we do a third roll, 1, 2, 3 shows up just out of randomness. So that's 1 plus 2, that's 6 divided by 3, so now the average goes to 2. Over time, it's going to approach 3.5 as we do more and more of these and calculate the average. So that's the law of large numbers. The more we do an experiment, the more it approaches the theoretical value. So in summary, probability helps us measure uncertainty. Uncertainties around us in all parts of our world. Most things are not known to exact certainty. Always things can happen a little differently than we think. And the two main types that we're going to deal with here are going to be theoretical and experimental. And the law of large numbers brings those two together. Well, I hope you learned a little bit about probability and got something out of this video. If you did, give me a like, a thumbs up, and subscribe to my channel. And thank you for watching.